When humans first went to the moon, they didn't land on the biggest crater. They didn't land on the tallest mountain. They picked the flattest, safest, most boring real estate that they could possibly find. And that decision tells us a ton about lunar geography. Today, we're starting this series with a simple rule. If it didn't land, it doesn't count. No orbiters, no flybys, no dramatic crashes. Only bots and boots. So, quick lunar geography primer. The moon is Earth's only natural satellite and our closest celestial neighbor, hanging out about 384,000 kilometers away from us. Cosmic backyard kind of stuff. It's about a quarter of the diameter of Earth, but only about 1/80th of the mass. That's why gravity up there is just 1/6 of what we feel here. You could dunk a basketball on the moon. You probably shouldn't, but you could, even if you're not good at basketball. It's less dense than Earth because it's missing a big iron core. It's mostly rocky mantle material, likely blasted off Earth after a giant impact billions of years ago. It has no real atmosphere, just a whisper-thin exosphere, made of stray atoms like helium and sodium that are constantly being blasted away by the solar wind and then replenished by micrometeorite impacts. No wind, no weather, no sound. One lunar day, it lasts about 29 and a half Earth days because the moon is tidally locked to us, which means 2 weeks of brutal sunlight followed by 2 weeks of pitch black cold. Surface temperatures swing from about 127 degrees Celsius in the daylight to negative 173 Celsius at night. It's covered in dark basalt plains called maria, ancient lava floods, and bright, heavily cratered highlands that record billions of years of impact. And underneath that dusty surface, lava tubes, massive ones, potentially big enough to hide entire bases from radiation. It's not just a rock in the sky, it's a frozen geologic time capsule. It changes the tides, it's influenced religions, politics, our calendars, almost every aspect of human life. It's a beautiful enigma that has both inspired and stoked fears in the hearts of men. Before humans set foot on the moon, the Soviet Union landed machines. In 1966, Luna 9 became the first spacecraft to achieve a soft landing on another world. It touched down in the largest lunar basaltic plain, or mare, the Oceanus Procellarum. This mattered more than people realize. At the time, some scientists were worried that the moon might be covered in deep, fluffy dust that would swallow a spacecraft whole. Luna 9 proved the surface was solid enough to support weight. Geographically, that was huge. And then in 1970, Luna 16 landed in the Sea of Fertility, and it brought lunar soil back to Earth robotically. Before Apollo 14 ever even flew, the Soviets had already pulled off an automated sample return. JFK even joked around famously in a speech in Philadelphia on October 29, 1960. Actually, he did it in several speeches, but in this one, about the Soviets, he says that, "You may be ahead of us in rockets, but we're ahead of you in color television." The audience laughs. I would rather take my television in black and white than have the largest rockets in the world. This was in response to a comment that Nixon made, saying that we may be behind in space, but we're ahead in consumer goods. So many in the US were aware that we were behind in space, but that was all about to change. Part 3, the US enters. So then came Apollo 11. Landing site, the Sea of Tranquility. Why here? Because it was flat. Mare regions are ancient lava plains formed billions of years ago when molten basalt flooded massive impact basins. Compared to the highlands, they have fewer steep slopes, fewer large boulders, smoother terrain overall. NASA needed gentle surface slopes, predictable lighting, near equatorial location for orbital mechanics, and direct radio communication with Earth. This was about survival. Apollo 11 didn't land where it was the most interesting. It landed where it was least likely to off them. And even then, Neil Armstrong had to manually fly past a dangerous boulder field before touching down. Geographically, this site represents the moon's volcanic past. The samples confirm the maria are solidified lava, not seas, not sediment, but frozen basalt oceans. Apollo 12, precision and regional diversity. So just months after that, Apollo 12 landed in the Oceanus Procellarum. Still a mare, still basalt, but not the same basalt. The chemistry differed from Apollo 11's site, showing that lunar volcanism wasn't uniform. Not all Maria are the same. Apollo 12 also intentionally landed near the robotic Surveyor 3 probe, so this wasn't about exploration anymore, it was more about precision. Geographically, this expanded our understanding of the regional variation across the moon's lava plains. Apollo 14 into the highlands. So then came Apollo 14. Landing site? The Fra Mauro Formation. Now we're leaving the smooth Maria and stepping into the rugged highlands terrain. The highlands are older, brighter, heavily cratered, and higher in elevation. Fra Mauro is believed to contain ejecta thrown out from the massive Imbrium impact basin, one of the largest collisions in lunar history. So this wasn't just about flat lava anymore, this was learning about impact history. And by sampling the Fra Mauro, scientists were effectively studying debris blasted out from deep space within the moon's crust billions of years ago. So if the Maria are lava oceans, the highlands are the scar tissue. So what's the big picture here? In just a handful of landings, robotic and human, we sampled 3 major lunar terrains: basalt plains, regional volcanic variation, and ancient impact ejecta. These weren't just random spots on a map, they were deliberate geographic choices. And we're just getting started because we haven't even talked about the mountains, the far side, the South Pole, and a lot more. And the South Pole is where the next space race is already starting to unfold. Listen, this is a world with regions, borders, and history. It's not just a blank rock. And in this series, we're mapping it. Make sure to stay tuned for the next part, and for now, check out my Martian geography series. Peace.